We nearly have a full audience. Yes, thanks to be here. I know it's very painful on a late Friday afternoon. So let me wrap up this. In about 15 minutes, I want to walk you through using LoRa ranging for recovery and then leave some room for questions. So basically, this is exactly what's behind the scene of this afternoon's demo that we did in Port of Amsterdam. But first, let's talk about airships. Before I dive into the Epic use case, this is a pure moment of ego show-off, okay? This is my next project. So the team is currently building probably the largest LoRa-controlled aircraft in the world. So this is a real helium-filled airship, and all the controls from the pilot to the engine, all is going to be done through radio. So this is the first fly-by-radio aircraft that's be commercially flying in the world. So we starting the test flight in a couple of weeks now. So basically, you can be a radio engineer and become a test pilot. That works. And I have to admit, it works infinitely better with women. I would strongly encourage you to change job. OK, what does Epic do? Epic is doing several things. We are designing and building that tracker here, which was the one that was dropped in the water this afternoon. It's designed for outdoor geosafety of mainly professional workers. We also provide the Epic Pro, which is actually a dedicated internet portal to monitor those guys and go, and monitor activity, dangerous areas, the forbidden zone, etc., etc. We provide a dedicated portal for security authorities, so rescue authorities. It's an automated way for them to request the last known GPS position of somebody they're looking for. So if you call 911 and they need to go and recover you, the first contact point will be this, where they will be able to fetch all the context of the search, and then they will take off with the helicopter to go and find you, and they will use this tool, the Finder, which is what I was using on board the boat. That Finder here is a dedicated tool to quickly and efficiently find a tracker, and I'll explain how that works. OK? So let's go now in really the recovery. This here is basically the only role of that device here is to perform the ranging measurement. So it's to handshake with your device and then perform the regular ranging exchanges that you need to be able to feed the software that's running on an Android platform. So basically, this and the software and actually all the intelligence is inside that software, and I'll dig a little bit on that later. One thing you need to know is this works, so it's been designed to work any environment, any condition, anywhere, anytime. So basically, it doesn't require any GPS. Your device may be completely GPS deprived, it may be interfered, it may be underwater, it may have not GPS at all. Actually, it could be a tag without GPS. Because the search is only leveraging sub-gigahertz LoRa ranging, all you need on board your tag is a sub-gigahertz chip able to do ranging exchanges. We have patented this what we call approach mode. This approach mode is actually a software helper that will guide your search and help you figure out where to go. Ranging is super cool, but it gives you a distance. It doesn't give you a bearing, right? So if you have no clue where to go, where do you direct the boat or the helicopter, it can become really quickly difficult. And I've done some searches in mountain where you have very low visibility, for example. It becomes increasingly difficult. So what this thing will do, it will actually, it will pinpoint for you the likeliest position of the device given all the ranging measurement you've been doing. So it does all the heavy lifting calculation for you. You simply have to actually direct yourself toward this icon here. The device can be indoor or outdoor. Because we do not rely on GPS, it will work everywhere. Okay? So I could be searching a device in that hall here, in that conference hall. It would work exactly the same. And my final precision is 1 meter. I'm not saying my precision is 1 meter. When you start the search, your precision is, shit, it's probably 50 meters. But the closer you get, the better it gets. And that's exactly what we need for a recovery. I just want a rough indication of direction at the beginning and distance. And as I get closer, it just updates, updates, updates in real time, and I finally pinpoint the device. No network either. I don't need GPS. I don't need network either. Those two things here talk directly to each other with a range of roughly 10 kilometers. They don't need anything else. So you could be in a totally white area deprived of any network coverage, any form of network. It will still work. You can test that anywhere you want on the planet. Okay, so that makes it super powerful because the recovery doesn't depend on any external factor, right? If you have a network, it's better because you have live GPS position. If I don't have live GPS position and I need to go in and rescue you, I will simply use the last known GPS position, and that will be enough to start a search. And then we'll find you. It's been tested and deployed in the field. So I've done countless search now. I'm fairly confident that works really well. We've done search mainly around our hometown of Grenoble. So these days, for example, was a helicopter test day. It's approved for aircraft use. So we've got all authorization to actually board public aircraft using this technology and use it on board. Actually, we're not the one using it. The French gendarmerie use it during the rescue. And it's been deployed in the French rescue organization. And we're currently in the process of deploying it also in northern Italy, Switzerland. What do I need to make my device findable? So that technology, today we use it for our trackers, but of course we'd be more than happy to actually license it to any application that may benefit from that recovery functionality. So the recipe is fairly simple. You basically need your device to be architectured around one of the LR11XX chips. So it can be the LR1110, the 20, the 21. All of those chips, they implement time of flight ranging. You need a sub-gigahertz antenna, either Europe or US, and you need a small firmware patch. We would provide you with a small, when I say small, it's literally small. It's like less than 100 line, very small, okay? So basically, any of those chips here is able to run recovery with exactly the same level of performance we're experiencing with our tag. If there's nothing magic in our tag that will do it better, your tag will do exactly the same, okay? What comes in the package, you need two things to do recovery, or three things. You need a low-power discovery mode. Basically, you need that finder to unshake with your device without taxing too much your battery life in the device. So you need a way to actually wake up the device from the remote and turn on the ranging. Okay, else nothing happens. Once you enter ranging, you can do intensive ranging exchanges. In average, we do several exchanges per second when we're in active research phase. But as you've seen this afternoon, the length of that is very short. In a few minutes, once you have initial contact with the device, the rest of the search is extremely efficient. It goes really quickly. Okay? And all the intelligence, so although the firmware patch on the device is very small, there is a lot of heavy lifting calculation happening in the finder, but actually all that resides in an Android, and we're currently porting into iPhone. So in a smartphone application, where actually we benefit from the power of this huge application processor, we can do a lot of calculation and a lot of real-time display. Okay, I'm kind of done talking about ranging. I wanted to show some other specificities, I think are specificities of our device. I think we have the first device which is able to roam both on our private network. We operate a private network of gateways in the French Alps. We also roam on all the TTN gateway Europe-wide. We also run on Sigfox network. And on second generation, we are porting Lacuna and EchoStar S-band on the device. So our device is 2 satellite providers, Sigfox, TTN, and our own private gateways, which is actually a fairly, I think, brilliant demonstration that roaming is starting to work. Demonstration. I did that presentation coming in here in the train, and here is my position record from our backend while I was crossing Brussels. So you see here, those are received by 4 TTN gateways, routing our packets to our private Actility NS instance. And here you see a Sigfox packet. So the device is constantly transmitting on Sigfox, LoRaWAN satellite, Sigfox, LoRaWAN, and opportunistically received. So even private-to-private network roaming is starting to work. It took 4 years, but we're getting there. It's starting to work. About satellites, we're currently doing a test with those two companies, EchoStar Mobile, which has a geostationary satellite covering Europe and US, so we're testing only the European one for the moment, and Lacuna, which has also an S-band satellite, which is polar orbit and available a few hours per day. So those two are actually very complementary for us, because EchoStar has continuous coverage, but it doesn't cover everywhere. If you're in a canyon or if you don't actually see the geostationary satellite, you'll never get anything through. My feedback on this is getting LRFHSS working, the protocol, all that is easy. The hard part is integrating a good enough antenna on your device. Antenna integration is going to be the challenge for satellite connectivity. And I'll keep that as a backup, and I'll basically open for any question you may have on this presentation. No question? No question?
You were mentioning that the device was for many professional stuff?
So for the moment, most of our applications are for professional outdoor users. But we also have, of course, trailers, paragliders, bikers, so people actually practicing outdoor sports, but on their own, which basically, if you go into an area without cellular coverage and you break your ankle, today you're screwed. They will dispatch the helicopter at night when you haven't come back home, but you will spend the night outside and we'll find you but frozen. So the difference between life and death is, can we find you before night arrives or after the night? And with the Epic Tracker, we're trying to find you before the night. So cold, but not frozen. Other question?
Yes.
We have time for one question if you want. No?
I have a question, though.
Yeah.
I'm wondering, what's your next step? Like, what's your bigger goal with this technology?
Funnily enough, after this afternoon demonstration, I got a crazy interest for maritime application, which I wasn't expecting. And honestly, for us, the big challenge ahead is integration of satellite connectivity. We're working on it. That will really transform the product, because for the moment, we have kind of a patch coverage. So we have excellent coverage in cities. Brilliant. This is exactly where we don't need it. So we need coverage in mountainous area and wild areas. We want to go in for the US market, where actually outdoor in wilderness is very popular. But clearly, to win in that game, we need consistent satellite connectivity, keeping it low power and low cost. Okay, so if we want to play head-to-head with Garmin's and Spot, so that's really what we are working on at the moment.
Awesome. Any other questions?
Thank you so much. I'm now in weekend.
Yay!